A cosmic conundrum. Where does the universe end? This question has puzzled humanity for generations. The universe is vast and mysterious, stretching far beyond what we can easily comprehend. It's filled with billions of galaxies, each containing billions of stars, planets, and other celestial bodies. But where does it all end? Is there an edge, a boundary, or something else entirely? What lies beyond the edge of everything we can see? Is it more space, another universe, or something we can't even imagine? These questions have captivated astronomers and philosophers for centuries, driving them to explore and theorize. The concept of an edge to the universe is a bit misleading. It's not a physical boundary like a wall or a fence. It's not like there's a brick wall out there in space, stopping everything in its tracks. Instead, the edge we're talking about is the limit of what we can observe with our current technology and understanding. Imagine yourself standing on a ship in the middle of the ocean, surrounded by water in every direction. You can see a certain distance to the horizon, but beyond that, your view is limited. Beyond that, the Earth's curvature hides what lies farther away. The universe is similar in this respect. We can only see as far as light has had time to travel to us since the Big Bang, which is about 13.8 billion years. This visible portion is what we call the observable universe, a small window into the vastness that lies beyond. Our limited view, the observable universe. The observable universe is a sphere with Earth at its center. This means that from our vantage point we can look out in all directions and see the same distance. It has a radius of about 46.5 billion light-years. This measurement is based on the farthest distance that light has traveled to reach us since the beginning of the universe. That's an incredibly vast distance, but it's still finite. The universe beyond this observable limit remains hidden from us. Think of it this way: if a star were to suddenly appear 50 billion light-years away, we wouldn't be able to see it for another 50 billion years. The light from that star would take an immense amount of time to reach our eyes. The light from that star simply wouldn't have had enough time to reach us yet. This delay is a fundamental aspect of our universe. Our current technology, even the most powerful telescopes, can only show us so much. These instruments, while incredibly advanced, are still limited by the speed of light and the age of the universe. Like looking through a keyhole, we are limited in our ability to perceive the full extent of the cosmos. Our view is just a tiny fraction of the entire universe. This limitation is due to the nature of light itself. Light, despite being incredibly fast, takes time to travel across the vast distances of space. Light travels at a finite speed, and the universe has a finite age. This means that there is a limit to how far we can see, defined by the distance light has traveled since the beginning of time. Beyond the horizon, scientific theories and speculations. So, what lies beyond the cosmic horizon? Scientists have proposed several theories, each more mind-boggling than the last. One possibility is that the universe is infinite. In this scenario, there would be no edge at all. Space would continue on forever, filled with an endless array of galaxies, stars, and planets. Another theory suggests that the universe is finite but unbounded. Imagine the surface of a balloon. It has a finite area but no edges. You could travel forever in any direction and never reach a boundary. The universe could be similar, existing as a closed loop in some higher dimension. Just like an ant crawling on the surface of a donut, we might travel vast distances only to end up back where we started. Section 4. Echoes of Infinity, the Multiverse Hypothesis. Beyond these scientific theories, there are even more speculative ideas. One of the most intriguing is the concept of the multiverse. According to this theory, our universe is just one of many universes existing simultaneously. These universes might be vastly different from our own, with different physical laws and constants. Think of it like bubbles in a cosmic foam bath. Each bubble is a separate universe with its own unique properties. Some universes might be teeming with life, while others might be barren and lifeless. The multiverse hypothesis is still highly speculative. We don't have any direct evidence to support it. However, it's a fascinating idea that captures the imagination and pushes the boundaries of our current understanding. Section 5. The Shape of the Unknown, Exploring Cosmic Geometry. Determining the shape of the universe is a key part of understanding what lies beyond the observable horizon. This quest takes us to the very edge of our knowledge, where science meets the unknown. Is it flat, like a sheet of paper? A flat universe would mean that parallel lines stay parallel forever, and the angles of a triangle add up to 180 degrees. Or is it curved like a saddle or a sphere? In a curved universe, the rules of geometry as we know them would change dramatically. The shape of the universe is determined by its density. The density of matter and energy in the universe dictates its overall geometry. If the universe is dense enough, its gravity will eventually cause it to stop expanding and collapse in on itself. This dramatic scenario is known as the Big Crunch. This is known as a closed universe. In a closed universe, space is finite but unbounded, much like the surface of a sphere. On the other hand, if the universe's density is below a certain threshold, it will continue expanding forever. This endless expansion leads to a scenario where galaxies drift apart indefinitely. This is known as an open universe. In an open universe, space is infinite and will keep expanding without end. Current observations suggest that the universe is very close to being flat. This means that the overall geometry of the universe is nearly Euclidean. However, there's still some uncertainty in the measurements. The exact shape of the universe remains one of the biggest questions in cosmology. Further observations and analysis are needed to confirm the universe's geometry. As our tools and techniques improve, we move closer to unlocking the true shape of the cosmos. Section 6. Unraveling the Tapestry: The Power of Observation and Imagination. The quest to understand what lies beyond the edge of the universe is a journey of both observation and imagination. We rely on powerful telescopes and sophisticated instruments to peer deeper into the cosmos. But we also rely on our creativity and ingenuity to formulate theories and hypotheses that can explain the mysteries we encounter. Every new discovery, every new piece of data, brings us closer to unraveling the secrets of the universe. And while we may never know for certain what lies beyond the cosmic horizon, the pursuit of that knowledge is what drives us forward. Section 7. An Everlasting Quest: The Future of Cosmic Exploration. The exploration of the universe is a never-ending journey. As technology advances, we'll continue to push the boundaries of our knowledge and peer deeper into the cosmos. New telescopes and space probes will be launched, equipped with instruments capable of detecting fainter objects and probing the universe's earliest moments. These missions will provide us with even more data and insights, helping us refine our understanding of the universe and its origins. The quest to understand what lies beyond the edge of the universe is a challenge for generations to come. It's a journey that will continue to inspire awe and wonder for as long as humans look up at the night sky.